This is a short concept introduction to flexfringe, a passive learning tool for the tool demo track. The key purpose of flexfringe is to convert a log file that is a long sequential representation of events created by software into something more compact. And by something more compact, we mean an actionable model that we can use for bug discovery or version control, or even for reverse engineering legacy systems that we actually can't have a better look at by looking at the source code, for example. And before we do that, we will briefly look at automata and state merging algorithms, but we will do that in a very informal way by looking at essentially graphical representations of the models we have, and also that will be examples learned with our tool to outline what types of model we learn and what you can see when you look at these models. And we'll do the same thing for the state merging algorithms, which is what drives our tool. We have a short animation that kind of explains, without looking at any code or pseudocode, what is happening in the background and how the algorithm generalizes the data. And then we'll focus on a case study with an industry partner where we can use either a Python interface or a command line interface. So the main focus of the tool demo will essentially be how to get good results with flexfringe using some data that is very much like the data from our industry partner. And we'll do that in an IPython notebook, and the advantage of the IPython notebook is that it can be downloaded by any participant and even be used live during our demonstration. I'll quickly walk through the basics of the tool, how to create an estimator object and how to use the estimator object, and explain how that is similar to other tools within the machine learning community. And once you cover these very basic steps, you can look at some data that we have from an industry partner and see how we convert this into a suitable format and how to then use the tool to obtain some graphical representations. We will also demonstrate how different parameter settings lead to different models, especially different models of different granularity, where you can see different types of bugs or different types of behavior deviations from a specification or from different versions of the software. This is also what the video currently shows. We started learning a machine with default settings that gives us the mealy machine that describes our data, but grossly overgeneralizes, and it returns a machine that has 3 states. And the original machine has 8 states, and we'll show how to recover this machine with different parameter settings. Another important aspect that we will not show in this IPython demo, but we will show in the C++ version, is how to customize merge heuristics and how to customize the models. In the meanwhile, we've recovered the original model in the notebook. So to summarize, we're going to show in the tool demo how to obtain actionable models for bug discovery and versioning control from sequential log files from software data. We will also discuss how to customize the merge heuristic and the type of model our software learns so that the software fits the domain-specific needs.